In this video, we're going to talk about graphing exponential functions using transformations. But before I get to that, I want to just remind us about the transformations. So this is a function, so this is g of x, and g of x is a transformation of f. Okay. Now we learned that something that looked like this way back when we were talking about transformations. So if you need a refresher, go back and look at that. It's going to be really important that you understand how to do those sort of basic transformations to be able to understand how to graph exponential functions. Okay, so what was going on here is we had g of x, transformation of a function that was called f, and then if you put it into this format. If you put g of x into this format, then you could see what the transformation is. So a was a vertical stretch or compression, and if a is negative, then it's a flip over the x-axis. B is a horizontal stretch or compression, and if b is negative, then it's a flip over the y-axis. And c is a horizontal shift, and d is a vertical shift. Okay, so now armed with this information, let's go ahead and do an example where we're graphing an exponential function using these facts. Okay, so now let's go ahead and start doing this example. We have g of x equals 2 plus 3 to the x minus 1 power. So the first thing we have to note is what is this a transformation of? Okay, so looks like, we'll define f of x. So this is like our starting function basically. So f of x is 3 to the x. Okay, so how do you find f of x? You just say whatever the base is and then just bring it to the single x power, right? So this is a simple exponential function. So very simple exponential function. That's going to be our starting point, and we're going to basically transform this to find what g is. So let me go ahead and rearrange g of x to kind of make it look like in that form that I had in the previous slide. So first I'll put 3x minus 1, and then I'll say plus 2. So I just kind of moved the plus 2 to the end because d is on the end on the previous slide when I was showing transformations. And I think it's important to kind of keep the order because eventually when you're doing the transformations, you do the transformations such that it's a, b, c, d. Okay, so now let's go ahead and write g with regards to f. Okay, so g of x is, well, let's see. I would have f of x minus 1, right? If you were to plug in x minus 1 into f of x, you would have 3 to the x minus 1, right? And then I have a plus 2 on the end. Okay, so in this this transformation, a is 1, b is also 1, so we don't actually have to worry about those. We just have the transformation c and d, which c was the horizontal transformation and d was the vertical transformation. So what are these transformations? Well, this c equals negative 1. This is a shift right by 1. Remember, if it's minus, then you shift right. If it's plus, you shift left. Okay, so if you shift right by 1, that's this f of x minus 1 when you do that. And then the next thing that we'll need to do is we'll need to shift up by 2. And that's this piece here, the plus 2. And then that'll give us f of x minus 1 plus 2, which is the g of x. Okay, so let's go ahead and graph this. So let's start with f of x. And so f of x is just 3 to the x. So any simple exponential functions like that are in this form that just are some number to the power x, they all go through where y is 1 when x is 0, right? Because if you plug in, it doesn't matter if it's 3 to the x or 5 to the x or any number to the x power, when it's 0, when x is 0, y is always going to be 1. So they all go through the y-axis at 1. Then I like to just plug in a few more points to kind of get an idea of the graph. So I always plug in 1 and 2, for example. So when x is 1, y is 3, and when x is 2, y is 9. And then we know the general shape of the graph. looks like something like this, okay? And you know, there's the horizontal asymptote there at y equal to 0, okay? So this, what I just drew, is the f of x. All right, so now let's do our transformations. So the first transformation, I'll do it in blue, so I'll do this transformation first. So shift right by 1. So I'm basically just going to take those 3 points that I did and shift them right by 1. Alright, so now I'm just going to do this in a dotted line because this is just one of the transformations. So I'm just going to do it in a dotted line so that we can see it. Okay, this is f of x minus 1. So I'm not done. I still need to do g of x, right? So I'm going to do this final. I'm going to do g of x in black, okay, and that's going to be the shift up by 2. You know, one thing I want to notice is that when I shifted right by 1, the asymptote, the horizontal asymptote didn't change. You know, the horizontal asymptote is y equal to 0, and it stayed the same if I shifted right. Now, when I shift up, I'm going to have to shift up the asymptote, right? So, you know, the asymptote is lying down here, and if you shift right or left, doesn't matter. It's, you know, it's an asymptote that goes right and left. But if we shift up or down, the asymptote will also then shift up and down. All right, so let's go ahead and do that first. The asymptote's at y equal to 0. I'm going to shift up by 2. So that means my asymptote is now going to be at y equal to 2. So I'm going to go ahead and draw that. This is y equal to 2. Alright, so now I'm going to go ahead and let's go ahead and do this shift up by 2. So I'm going to take this first point here. It's at 1, 1, and I'm going to put it at 1, 3. Oops, let's see. Right there. Okay, now next I'm going to take this point that is at, let's see, it's at 2, 3. I'm going to shift it up 2. So then it'll be at 2, 5. Okay, and then I'm going to take this last point, which is at 3, 9, and I'm going to bring it up 2. So it'll be at 3, 11. Okay, now I'm going to draw this, keeping in mind my asymptotes. Alright, so it's going to look like this. So that is g of x. Alright, and then, so we've graphed g of x now. Looks something like what I have drawn there. So now let's go ahead and state its domain. Let's do that first. So what is the domain? The domain is unrestricted, negative infinity to infinity. Okay, you can put anything in for the power of x, and that's okay. Let's do the next one, the range. The range is restricted by the horizontal asymptote, right? We never go below the horizontal asymptote. So the range, all the values of y that are in this function, are just from 2 onward to infinity, but not including 2, because we never reach 2 with this asymptote. So 2 to infinity. And then last question is, what is the horizontal asymptote? Well, we know that to be y equal to 2. Okay, let's do one more example. This example is a little more difficult than the previous one. So let's go ahead and get started with it. First thing you need to do is you need to recognize what you're going to be transforming. Okay, so what is f of x? And I said that you should take whatever the base is and bring it to the x power. That's always what f of x is going to be. So this will just be 2 to the x. All right, so I'm transforming 2 to the x. So what is g of x? So what is g of x with regards to f of x, I guess I should say. So g of x is, well, we have the 3 outside, and we're multiplying that by f of negative x, right? If you were to plug in negative x, you would get 2 to the negative x, which is what you see here. Okay, and then we need to subtract off 2. All right, so what are our transformations? So the first transformation is a vertical stretch by 3. So vertical stretch by 3. Okay, that's this first term out front. That's referred to as A in our first slide. Okay, so the vertical stretch by 3. That's basically, so if you do that, then you'll end up with 3f of x. Okay, if you do that first. And then the next one is this negative sign out here. That's b in our in the beginning, first slide. So what does the negative x do? That does the flip. So when b is negative, so b is basically negative 1 here, then you flip over the y-axis. All right, and so if we do that, yeah, I should make sure that this isn't confusing. So that's not a negative 3 there. So if we flip over the y-axis, that's going to give us 3f of negative x. Okay, lastly, the last step is to shift down by 2, and so that's this last piece here. That's d in the if you were to look at the first slide, we refer to this thing that's on the tail as d. Okay, and since it's negative, that's why it's the shift down. All right, and if we do that, then we'll have 3x negative, okay, minus 2, which is g of x. So this last step will give us g of x. All right, so now let's go ahead and let's do these 3 steps. So first, let's go ahead and start with the function f of x. All right, so we said in the previous, when we were drawing f of x, we always go through this point at 1, because if you plug in 0 for x, you'll get 1. Now let's go ahead and just do a few more points to help guide us as we're doing these transformations. Let's do the point 1, 2, right? If you plug in 1 for x, you get 2. If you plug in 2 for x, you get 4. What the heck, I can do maybe another one. So if you plug in 3 for x, you get 8. Okay, so, and we know we have this horizontal asymptote here at y equal to 0. So it looks something like this. Okay, this is the f of x function. All right, so now let's do this first transformation, the vertical stretch by 3. So how do we do that? We basically, so we're going to multiply, any of so the x, or sorry, not the x, but the y portion of the point by 3. Okay, so starting here at this first point at 0, 1, okay, when you multiply 1 by 3, you get 3. So it'll be 0, 3. And then the next point, so it was at 1, 2. If you multiply 2 by 3, you get 6. So this will be the next point up here at 6. So it'll be 1 and 6. And then this point here is at 2 and 4. You multiply 2 by 4, or sorry, you multiply 3 by 4, right? You multiply whatever the y is by the stretch. So if you multiply 3 by 4, you get 12. So, let's see, that's like right here. Okay. All right, and then the stretch does not change my vertical asymptote. So if I were to draw this, it would look something like this. All right, and so this is the first step. This is 3f of x. All right, so now let's go ahead and do the next step, the flip over the y-axis. So if we flip over the y-axis, basically let's take whatever the y-coordinate is, or the x-coordinate, sorry, take whatever the x-coordinate is and then make it negative. Okay, so this first point here, when x equals 0, that'll stay itself because negative 0 is just 0. And this next point, where it's 6, 1, is now going to become 6, negative 1. Okay, so you see how that flips it over the y-axis, right? And then let's see, we have one more point here at 2, 12, so that's going to be negative 2, 12. So I'll do that here. Okay, all right. And my graph now looks like this. My vertical asymptote didn't change. I'm still at y equals 0 for the vertical asymptote. All right, so this graph that I just drew in green is 3f of negative x. Okay, lastly, shift down by 2. So let's take all the points and shift them down by 2. And this shift down will move the vertical asymptote. Alright, so remember, it's only shift ups and downs that move vertical asymptote, or move horizontal asymptotes. Okay, so let's go ahead and get started with this first point at x equals 0. So instead of it being at 3 and 0, or well 0 and 3, x equals 0, and then y equal to 3. So I'm going to shift it down, so it's going to be down by 2. So instead of it being at 3, it's going to be down here at 1. Okay, and then 6 is going to shift down 1, 2 to 4. So the point will be negative 1, 4. Okay, then lastly, the 12 is going to go down 1, 2 to 10. So that's going to be negative 2, 10. Alright, so, and then also, where's my asymptote? Okay, it went down by 2. So it was at y equals 0. Now it's at y equals negative 2. Down by 2. So this is y equals negative 2. Alright, so let's go ahead and try to draw this. You know, I really wish I had graphing paper to try to help in this, but something like that. Okay? You get the idea. So there we go. There's there's g of x. Let me go ahead and mark that, g of x. Alright, then let's go ahead and, what's the domain? The domain of this is negative infinity to infinity. We can put anything in for x. What's the range? So the range is restricted by the horizontal asymptote, and that's at y equals negative 2. So we can go from infinity, really high values of y, all the way down to negative 2. So negative 2 to infinity, soft bracket. We don't include negative 2 because we don't ever actually reach it. And then the horizontal asymptote is y equals negative 2.